policy and economy in energy, environmental issues. In this video, we'll talk about environmental issues in the energy sector. At the end of this module, you will be able to understand the environmental issues related to the energy sector. Energy and environmental problems are closely related, since it's nearly impossible to produce, transport, or consume energy without having a significant environmental impact. All forms of electricity generation have an environmental impact on our air, water, and land. Scientific evidence related to the warming of the climate system is unequivocal, according to the Intergovernmental Panel on Climate Change. The global average temperature has increased by more than 1 degree Celsius since pre-industrial times. Over the last few decades, global temperatures have risen sharply to approximately 0.7 degrees Celsius higher than 1961 to 1990. The largest human influence has been the emission of greenhouse gases, with over 90% of the impact from carbon dioxide and methane. Fossil fuel burning is the principal source of these gases. Global emissions increased from 2 billion tons of carbon dioxide in 1900 to over 36 billion tons 115 years later. Carbon dioxide emissions associated with energy comes from a range of fuel types. The contribution of each fuel type has changed significantly through time. In the present day, solid and liquid fuels dominate. The world's primary energy demand continues to grow and will likely continue to grow over the coming decades. According to the forecast of the International Energy Agency, the global energy demand will increase by 30% in 2040, and the global electricity demand will increase by 40% in 2040. Most of this growth is influenced by India and China. Despite the demand increase, some people remain without electricity access. A part of the population gained access, but the population growth tempered this progress. About 1.1 billion people still do not have access to electricity. Climate change is a global problem and must be tackled together. The first Kyoto Commitment period ended in 2012. Therefore, intensive international negotiations on an effective new global treaty was ongoing. In December 2012, at the Doha Climate Change Conference in the UNFCCC, parties to the Kyoto Protocol adopted an amendment to the Kyoto Protocol. In accordance with the Doha Amendment to the Kyoto Protocol, the parties have committed themselves to reduce greenhouse gas emissions by 20% of base year, mainly 1990 till 2020. On the 12th of December 2015, 197 countries of the UNFCCC have agreed on a legally binding climate change agreement that sets emission reduction commitments from 2021 onwards. The agreement came into force when it was ratified by more than 55 countries. The parties have agreed to work together to ensure that the average global temperature stays well below 2 degrees Celsius since the Industrial Revolution and to stop global warming at 1.5 degrees Celsius. To this date, 189 of 197 parties have ratified to the convention. In order to achieve the Paris Agreement, it's necessary to reduce global emissions to around 85% compared to 1991 level by 2050. It may take decades to transform our energy systems. The most important CO2 emission reduction measures are energy efficiency, renewable energy, fuel switching, carbon capture, utilization, and storage. Renewable energy and energy efficiency are complementary, and they need to be stepped up in parallel. Energy efficiency offers the most cost-effective options for meeting global greenhouse gas emission reduction targets. Energy efficiency first principle should be applied. Producing and using electricity more efficiently and cleaner reduces the amount of fuel needed to generate electricity and the amount of greenhouse gases and other air pollution emitted. The cheapest, cleanest, and safest energy is the energy we don't use. Worldwide, the IEA estimates that efficiency needs to contribute to about 50% of greenhouse gas emissions cuts. This makes it the cornerstone of global action to fulfill the Paris Agreement commitments. Every 1% improvement in energy efficiency means saving the equivalent of the annual CO2 emissions of 12 million cars. In parallel to energy efficiency, renewable energy has a key role to play in the decarbonization of the energy sector and the resulting mitigation of climate change effects. Renewables imply deployment of renewable technologies in the power sector, as wind, solar, and photovoltaic, and end-use direct applications, such as solar thermal, geothermal, and biomass. Renewables can reduce the CO2 emissions from the energy sector by 70% in 2050. Renewables would need to comprise at least 2/3 of the total final energy supply by 2050. At the same time, the share of renewable energy in the power sector would need to increase from 18% in 2017 to 86% in 2050. There are technically feasible and economically attractive solutions at hand to achieve this goal. Indeed, there is a unique opportunity to accelerate transformation towards digitalized, distributed, and decarbonized energy systems. Carbon capture and storage, also referred to as CCS, is an important emissions reduction technology that can be applied across the energy system. CCS storage processes include capture of CO2 from industrial emissions, transportation, and storage into geological layers. CCS technologies can capture up to 90% of industrial sites' emission. The high cost of CCS has thus far kept the technology from entering mainstream use. Future cost reductions will depend on the deployment and adoption of commercial technologies in the marketplace, as well as sustained research and development. In order to reach the greenhouse gas emission reduction targets after 2020, the deployment of CCS technologies will be crucial. The environmental issue is the increase of the mean temperature over the globe. Human activities, and notably energy production, produce greenhouse gases. Mitigating environmental issue implies reducing these emissions. From the energy perspective, the main levers are energy efficiency with more effective appliance and building, insulated buildings, and effective means of production. Renewable energy for producing electricity or use is as end-use application such as heaters, solar furnace. Finally, carbon capture and storage, which contribute to manage unavoidable carbon production. Thanks for watching.